In this video, we're going to solve the chair conformations bonus quiz question B, turning a chair conformation into a Newman projection. You can find the entire quiz along with the chair conformation tutorial series on my website, leahforsyth.com/chairs. Make sure you also review Newman projections tutorial series link below or leahforsyth.com/Newman projections. The tricky part in going from a chair conformation to a Newman projection is that you're taking a molecule presented in one strange way of looking at it and converting it into another strange way of looking at it, right? Chairs and Newman are just different ways of looking at molecules. The trick to simplify this is to recognize what you're looking at and find a way to make the initial chair directly look like a Newman projection. In the Newman projection series, I teach you to take the carbons that you're looking at and imagine wrapping your fingers around it to create that Newman projection ring. So we are going to sit ourselves right here, facing the chair conformation. So this is you facing the molecule, this is the back of your head, your hair, you're looking in that direction. And you're taking your hands and wrapping it around the sides of the chair. You're holding the model in a way that your fingers create that Newman projection ring. These represent your fingers, this would be your hands. Let's take a look. This chair conformation does not have all the substituents we saw in the example, but the concept will be the same. You want to imagine that you're isolating the ring and only focusing on these two carbon atoms right here. If this is going to be our Newman projection, imagine grabbing the ring, wrapping your hand around. This will give you that circle that you see in Newman projections. We're holding it right here. Front carbon is visible. Rear carbon is not because we're blocking it, and that's okay. So long as the rear substituents are showing, which we'll try to see past my fingers. We have a methyl group going down there. We have a hydrogen down there. We have the red hydrogen, and then the rest of the ring. We'll do the same thing to the other side. We're looking at these two carbons. We're looking from this one down to this one, so we take our fingers, wrap it around, and when you hold your chair like this, I want you to start imagining right there is where your Newman projection starts to form. Instead of hands, let's draw that as the Newman projection ring. So we'll put one circle right here and another one right here. With a standard Newman projection, you see 3 bonds coming out of the front of the Newman and 3 bonds behind it. They can be written as a Y or an upside down Y. And when going from a chair to a Newman, instead of picking which one, let the chair show you by first adding in all the invisible hydrogen atoms on the right and left carbons of the chair. On the right lower carbon, we have a methyl group going down, so that means we have a hydrogen in the equatorial up position. Here we have a hydrogen in the axial up, hydrogen equatorial down, and hydrogen axial down. Why do we need to see this? Ask yourself, based on seeing the 3 atoms coming out of this carbon, do I have a Y or an upside down Y? We'll have to use our imaginations to tweak it a little bit, but here we have a Y, and here we have the upside down Y. On the other side, upside down Y and regular Y. This is really all you need to see. Everything else will fall into place when you redraw it. Start with your hands, which are the circles, and place your Y or upside down Y. On the right, we have a Y in the front, upside down Y in the back. On the left, we have a Y in the front and upside down Y in the back. Then it's simply a matter of copy and paste. On the forward carbon, we have a methyl group in the down position. We have a hydrogen upright. And in the up left position, we have the carbon that connects the right Newman projection to the left to complete the ring. Instead of a CH2, which you normally expect, in this case we have a fluorine and a hydrogen, so that's a CHF. And we can simply draw that here as CHF, or you can draw it here as CH and show the F going down. You might have to tweak it a little and reform your Y so it connects to that CH group. Let's move on back. For the rear carbon on the right, we have a hydrogen in the up position. We have an isopropoxy, an isopropyl on an oxygen, giving me an ether going down and towards the right. And towards the left, we have a CH2 that connects the ring. So that right here would be a CH2. Moving over to the carbons on the left, for the forward carbon, up and towards the right, we have an OH group. Down is a hydrogen, and we already have the CHF over here in the up position. For the rear carbon, in the up position, we have a carboxylic acid. Going down and towards the left, we have a hydrogen atom, which completes the Newman projection. At this point, make sure that every carbon has the correct number of attached groups. Start with a Newman and make sure your Y or upside down Y does have 3 things attached, where the middle is a carbon that connects the right and left side of the ring. We have 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. To summarize, the trick here is to imagine grabbing the model kit here and here, figuring out if your carbons have the Y or upside down Y, and then superimposing all of your substituents. Make sure you try the rest of the quiz on my website, leahforsci.com/chairs.